Hello, this is our final evidence for our chemistry experimentation class. Our team members are Daniela Ramirez Hernandez, Miguel Ángel Quintanilla Sáenz, Luis Ronaldo Castillo Cerda, and Alberto Abraham Banarico. Okay, so what are fossil fuels? In today's world, oil has become the most common fuel source. It's estimated that over 90% of transportation being powered by oil, and said transportation accounts for two-thirds of oil usage worldwide. Many people depend on oil for their life, which has led to scarcity and high price increases in the market. One of the largest problems about oil is the environmental issues it causes, due to their usage contributing to climate change with the release of greenhouse gases like carbon dioxide. Luckily for our society, there exist various different alternative energy sources. First of all, galvanic cells. Galvanic cells are electrochemical cells that convert chemical energy into electrical energy through spontaneous redox reactions. The cell is divided into two, with an anode, which is negative half, and a cathode, positive half. In the anode, oxidation occurs, while in the cathode, reduction occurs. Two electrodes are placed into these half cells, where the oxidation causes a loss of electrons and reduction a gaining of electrons. Some of the pros of using galvanic cells are that it's a renewable energy, it causes less greenhouse gas emissions, and it has a high energy efficiency. Some of the cons are high initial costs, it has a slow recharge, and there are disposal environmental concerns. The second option are solar cells, which are also known as photovoltaic cells, which are devices that convert sunlight directly into electricity. When sunlight hits the solar cell, it is absorbed by a semiconductor material. The energy from the sunlight excites electrons in the material, freeing them from atoms. These now free electrons move through the material and produce an electric current, which can be used to power electrical devices or be stored in batteries. Some of the cons are that this is a renewable source of energy, it has low operating costs, and is environmentally friendly. But some of the costs is the high initial cost, it is weather dependent, and it has a large space requirement.
Fuel cells are electrochemical cells that directly convert the chemical energy stored in certain fuels, most commonly hydrogen, into electrical energy, and they work as follows. Firstly, you introduce the fuel into a cell, and as the fuel is being introduced, the protons and electrons are separated. While the protons move through a proton conducting membrane, the electrons move along an external circuit. This is what produces the electrical current. Now, when the electrons and protons recombine with the oxygen on their journey at the other electrode, byproducts like water and heat are generated. Fuel cells have various pros and cons. The pros being that they are extremely clean. They produce clean energy, especially the hydrogen fuel cells, since they utilize green hydrogen. Green hydrogen being a form of hydrogen that is produced using renewable energy. Fuel cells are also extremely efficient and they are quick at refueling. However, the cons are that the green hydrogen used costs a lot to produce and is also hard to produce. There's a difficulty where you store the fuel. For example, hydrogen is a substance that is hard to store to keep it at like the best quality. And finally, it's not a very durable cell. There are various durability issues with it. Now we have to talk about the objective of our lab experiment. So, in order to try and minimize the pollution, our team was tasked with researching various different alternative energy sources. These sources being galvanic cells, solar cells, and fuel cells. So, in order to further test the efficiency of said energy sources, our team was tasked with creating a galvanic cell with the purpose of powering a small toy, the toy being the one in this slide. Our team also later tested the same toy with a solar and fuel cell in order to compare the efficiency and how they worked. Now we must explain how we built our galvanic cell. When building our galvanic cell, we used a magnesium bar, a copper tube, and around 30 to 40 milliliters of our copper sulfate solution. In order to build the cell, we followed these steps. Firstly, we sanded the copper tube both inside and out, and our magnesium bar. This is done to clean any residue or impurities and make sure that our galvanic cell works correctly. Then, in a 50 milliliter beaker, we added around 30 to 40 milliliters of our copper sulfate solution. We also then wrapped our magnesium bar with paper towels. This is done so that we can avoid direct contact between both electrodes, the bar and the tube, since the bar goes right in the middle of the tube, and if both electrodes touch, a short circuit happens and the galvanic cell would not work. Finally, we place the bar and the tube inside the solution filled beaker. And this is how our galvanic cell is built. Now, after building the cell, we measured a total potential of 1.379 volts with our multimeter. This is different from the theoretical potential we calculated, since we think that it should be 2.7 volts.
Once the cells were built, they were measured with a multimeter, both voltage and current, and then tested with a small toy. As can be seen and heard in the videos, the galvanic cell and the fuel cell could only generate enough voltage for the toy to make a few noises, while the solar cell even made movements. This is because the galvanic cell, which was made of copper and magnesium, had a cell potential of 2.7 volts, of which the cell could only provide 1.4 volts. Once the fuel cell was charged, it could only provide 1.14 volts, which prevented the toy from functioning properly. However, the solar cell was able to provide 2.25 volts when exposed to direct sunlight, which was enough for the toy to function properly. However, when the solar cell was tested inside the laboratory, where there was no direct sunlight, it could not properly operate the toy, providing approximately 1 volt.
In conclusion, our experiment aimed to evaluate alternative energy sources by testing galvanic solar and fuel cells to power a toy, seeking cleaner options than fossil fuels. The galvanic cell, constructed from magnesium and copper, yielded around 1.4 volts, less than its 2.7 volts theoretical potential, managing only to turn the toy on partially. The full cell faced assembly difficulties and provided 1.14 volts, similarly, only partially powering the toy. In contrast, the solar cell, talked inefficiency in indoors, successfully generated 2.25 in sunlight and fully powered the toy, making it the most effective method under the right conditions. Key issues identified were the galvanic cell's voltage discrepancy, the solar cell's dependencies on sunlight and the irradiation, the full cell setup challenge, and the insufficient power from both galvanics and fuel cells.
Some improvements that can be done for this project are choose electrodes that have a higher potential difference, increase the concentration of the electrolytes used, use cells in series to increase the voltage produced by them, using catalysts to make cells produce energy faster and more efficiently, control temperature and pressure to make cells more stable and efficient, and use different types of fuels for the fuel cells and different types of metal for the galvanic cells.